Me too. Thank you all for coming in. To our friends online, thank you for tuning in as well. Let us know if you can't hear or see us correctly, but we're excited. We have a good evening planned for you today. So I know there's a lot of big decisions that you guys are making right now, and there's a lot of uncertainty and a lot of information going around. So we really hope that today we can give you a true look into what it's like to be an engineering student at UOA, and particularly a female engineering student. All of these people who are speaking today were in your shoes not too long ago, like very few years ago. I was there too. So hopefully we can answer any questions you have and anything else. So we've got a good evening planned for you today. And without further ado, take it away, Julia.
Okay. Hello. Oh, I have to figure out how close. Okay, I think that's good.
Yes.
I think so. Kia ora tātou, ko rangitoto te maunga, ko Long Bay te awa, no Tamaki aho, ko Ford toku whanau, ko Julia toku ingoa. Greetings all, Rangitoto is the mountain, Long Bay is the river. I am from Auckland, Ford is my family, and my name is Julia. So that's a quick introduction to who I am. I'm also a Part 2 civil student and the leader of the Part 1 WIN team. So if you do end up deciding that engineering is what you want to do, then hopefully if I'm still in the position next year, I'll be seeing you a lot.
Brilliant. Thanks, Julia. So my name is Ananya. Kia ora. I am in the I'm an event coordinator and I'm in the finance and ops team. I'm also a Part 3 software engineering student, so I'm also doing a conjoint with commerce, majoring in finance and economics. So if you guys have any questions after as well, you can come meet us at the end of the event. Cool.
So I think so, yeah. So a quick rundown of the program for tonight. So we're first going to start off with an introduction to what engineering is, because it's a very broad and, if you've never been around any engineers, it's really hard to think of what it actually means. Then we're going to go over the engineering specializations, and each of the speakers from each specialization is going to talk about their experiences. And then afterwards, we're going to have a student Q&A panel where you can chuck through some questions, I believe. No, never mind. I will put up a slide in a few minutes with a Slido, but we'll run through how that all works.
Mm-hmm. Awesome. So do we want to go right into the big question, what is engineering? Now, don't worry if you don't know. I have some people who are in the degree right now in Part 3, and when they get asked the questions, they're still stumped. So engineering, as it says on the big words up on the screen, engineers are problem solvers. So they use science and maths to solve everyday problems that come up. So you'll be designing solutions, optimizing what already exists out in the world out there, and basically just making a difference kind of thing. It's very broad, it is, but I'd like to think that it's so broad that everything kind of factors, you see it every day in your life. You interact with engineering every day. So there's a place for everyone in engineering. So do you want to?
And then these are some of it's hard to list a couple of the problems just because there's so many that engineers are involved with. But these are some of the main ones that you can contribute towards solving. So there's some huge problems there that are, when you graduate with an engineering degree, you get to design solutions that can contribute towards these things, which is pretty exciting. So some of the big ones: climate change, access to water, health, transport, which impact all of us and everyone around the world.
Awesome. So as we've mentioned, engineering is very broad and there's a lot of different sectors to it. So at University of Auckland, we've got 10 different specializations for you, as you can see up on there. And so it's a nice little look into how engineering can be for everyone. And you guys are all lucky enough that in your first year of engineering, you get to try out every one of these throughout your courses. And at the end of the year, you can find, after evaluating what you found most interesting and what you're most passionate about, you can pick one of those into second year and you can rank your options. For example, I really, really loved my coding paper in first year, whereas my best friend who went to the same high school as me, did the same education, she seemed to really love the civil paper. So now I'm in software and she's in civil, so it all kind of worked out. So engineering really is for everyone. And you can make sure at UOA that you find what fits for you.
and a little bit of an intro to WIN. So these are some of the main 3 goals that we have. The first one being encouraging girls into engineering from high school. And so we have an Ingenuity Day, I believe halfway through July, where you kind of come in and dip your toes into all of these different engineering activities and challenges. And then, when we hook you into engineering, then WIN is there to support you throughout your whole degree, and we host so many social events and networking events, help you get an internship and then a job afterwards. And then we move on to the post-university, so we're developing like alumni, a little alumni community of all past WIN members.
Awesome. So as Julia said, WIN is with you like every step of the way, and specifically while you're at university, we have a lot of events stemming from like networking events, professional development events, and my favorite, social events. So we have like the event that everyone looks forward to coming up in a little bit called the WIN Dinner. We had a very successful WIN cocktail night, which was very exciting, I can say. And we also have different branches to WIN as well. So we have WIN Allies, we have WIN Mentoring, and we have all of this stuff here. So it's very exciting. I think WIN is my favorite part of engineering, I'm not going to lie.
And then, like I said before, I'm part of the Part 1 team. So if you do end up doing engineering, we've got a special team that's made just for you guys as Part 1 students. And in that, we run a lot of social events to try and like introduce you to all of your other cohort and your other female engineering peers. We run study sessions. We have a spec night, which kind of gives you a little bit of like guidance and wisdom in your in making your decision for what spec you want to do. And then we provide like online support, and we have like little Facebook groups and Discord channels, because apparently Discord is what you guys are using now, not Facebook, which I realized 3 months ago. But yeah, so definitely supported in all throughout your degree with WIN.
Ideal. Okay, so we also have a Slido going on. So this is for the Q&A part that will come up at the end of the event. So if you guys have any questions while the speakers are speaking, or if you have any pre-existing questions, just go on the link, type in the code, and put all your questions on there. And also, you can also scroll through and see the questions that are up there and like upvote the ones that you like, and we'll answer them at the end. We'll do our best to answer them all. So yeah, that's the link. Yeah, the code is actually WIN. It shouldn't be hard to remember.
Perfect. So we're going to get straight into it because we've got a lot of specializations to get through. So we're starting off with the ECSC Electronics, Computer Systems and Software Engineering faculty, which is quite a mouthful. And first I want to introduce Jenna from software.
Hey everyone, I'm Jenna and I'm a 5th year software engineering student. So I'm a conjoint studying commerce, that's why my degree is a little bit longer. So what is software engineering? So software engineering is all about working in teams to create, design and maintain high quality software systems. When I was in your shoes, I didn't really know what I wanted to do. I didn't really have any particular passions. I did enjoy maths and physics, so that kind of got me thinking about engineering. And because I learnt in your first year, like how you get to try all the different types, I was like, oh, this is great, because then I can just take it and decide later what I want to do. So if you're indecisive and you don't know what to do, engineering's a great option for you. And I'd also heard from older students how powerful an engineering degree is. Like I'd heard that people were able to work in different industries like banking and business and finance, all with an engineering degree. So I thought, wow, this degree will give me a lot of flexibility, and that's why I decided to choose it and haven't looked back. Oh, wait. Sorry. So, what made me choose software? Well, again, I was really indecisive and was choosing between a few different things. However, the course that I mostly enjoyed was the programming course. I just liked the fact that I could type a few lines of code and then something would appear in front of my eyes, and I was like, oh my God, this is like the closest thing to magic. Like I get to make something and all I need is my computer. So I decided to pick software. However, I was a little bit hesitant because I was worried that I wouldn't fit in, that people might not look like me there, because in my mind I thought a software engineer was someone who, was coding in a hoodie, had never seen the sunlight, and had no friends. But turns out we are, we are really, a bunch of interesting people, and I've met the most coolest people in software. I mean, look at us, we look pretty cool, right? That's me and my software engineering friends. And now more about the degree. So in your first year of software engineering, it's a little bit more theory-based and more about what makes good quality software. And then as you progress throughout your degree, you get to choose more of the courses you want to take depending on what interests you. So there's things like human-centered design, which is like a UI course. There's like network courses. There's plenty of other electives, so if you're into machine learning, you can take a course on that. A lot of the courses I took were centered around web app development, where we got to work in big teams and create a web app. So the picture there on the right is a task management web app that I got to create. And there's also a lot of tech clubs that you can get involved in, and they're really helpful for progressing your career. So I learned a lot of CV tips from them, and as well as that, there's so many informative tech events that are on to help you with your personal projects. So there's a lot of support in terms of extracurriculars if you choose to do software engineering. And now a little bit about career pathways. So typically you would graduate as a software engineer and you'd work as a software engineer. And I do want to mention that the role software engineer is synonymous with software developer. They pretty much mean the same thing. And there's usually two types, which is back-end and front-end. But among that, you can go into so many other different fields within software engineering that are a little bit more niche, such as data analytics, security engineer, site reliability engineer. And as I mentioned before, you can even go into other industries. So many employers and other businesses just love people that can code. It's a bit of a superpower. They just want programmers because they know how useful learning programming is. So if you're worried about job security, don't worry if you're studying software engineering. And a little bit about where I've worked. So I worked at Honeywell, which is a company in Sydney where the product I was working on was a web app to help show data about, it was a web app to help business managers manage data about their buildings, such as how much energy their building was consuming, the temperature. So it was quite cool knowing that I was working on a product that would help all these companies improve the way they operate. And currently I'm working at a company called Atlassian, which makes products for teams, so team management software, and I'm actually working remotely from them as well. So a huge perk about tech companies is that a lot of them give the option to work remotely, so that offers obviously a lot of flexibility. And the two other things that I really like about working in the software space is, firstly, because the software industry is so young, a lot of the companies have a very youthful and lively atmosphere, with open plan offices. Some big tech companies have free breakfast and lunch and all these activities going on, so it's a really exciting place to be. And the second thing is the work-life balance. Obviously, I can't speak for every company, but a lot of tech companies in Australia and New Zealand have great work-life balance, and you get paid a decent amount. So, yeah, I'm so glad that I decided to choose engineering, and I'm so glad that I didn't let the stereotypes of, what a software engineer looks like and all of those things prevent me from taking it. I'll pass it on to whoever's next.
All right. Thanks, Jenna. Remember, if you have any questions about software or conjoints or for Jenna specifically, just put them on the slider and we'll get to them at the Q&A. Right, next up we have Akila from Electrical. So take it away.
Good evening, everyone. I'm Akila. I am a Part 4 Electrical and Electronics Engineering student. Final year, yay. So a little bit about me. I went to Botany Down Secondary College. Is anyone here from there? Nice. So I did my high school at botany. A little bit into engineering, my journey into engineering. I took calc and physics, and I really enjoyed it. In high school, I had good teachers, thankfully. So I got into engineering kind of through WEN. I don't know if all of you know about Ingenuity Day, but it's basically a day that WEN hosts where it's open to year 12 and year 13, like physics and calc students. You come into uni and we do a lot of workshops. We work with you work with like part 2 and part 3 engineers, and you do a few workshops, and it kind of gives you an insight into what engineering is, that it's much more than just physics and calculus. It's a lot about design, there's so much building, there's a lot of teamwork, all the soft skills that go into it. So that's sort of how I got into engineering. And then electrical. So electrical is not an elective, sorry, it's a core paper that you do in the second semester of your first year. And you do several topics. You do like a bit of power systems, you do a bit of kind of like an introduction to electrical. It's kind of like a continuation of what you're doing at high school right now. So why engineering in general? So engineering is the amount of difference that engineers make in your day-to-day society is it's pretty amazing. You don't realize how much work goes into it, into each building, whether it's a building or whether it's a transport project, whether it's a little distribution or switchboard unit, whatever little, the amount of impact that electrical engineers and all engineers make in society is pretty amazing. I've come sort of from a background of engineers, so I already know a little bit about it, and that's kind of what inspired me to take up this profession. The money, of course, it's pretty amazing. I don't know if you've done your research, but engineers make a decent amount of money, like Jenna mentioned earlier. Your job prospects, if you're someone that's looking to, broaden your prospects, go outside of New Zealand, engineers, I guarantee you have a job available almost anywhere in the world, so you don't have to worry about that. Next slide, please. So a little intro into electrical and electronics engineering. So from second year on, you kind of split up into different specializations. And within electrical, they give us an intro into power systems, radio engineering, engineering design, which is personally my favorite, signal processing and control systems. I'll talk a little bit about my favorite paper, which is engineering design. So it's kind of a project paper. You work in teams of 3 to 4. You come up with a design and you kind of build it from scratch, which is pretty great. You don't really get to do that. The fact that you get to do that in second year is pretty amazing. So you kind of design it using various softwares. You get to test it also using like LT-Spice, which is like a circuit software, and then you get to actually build and test it in the labs. Power systems, if you're into your power systems, it's more about like distribution and generation. You get a little bit of an intro into that. Also a very cool paper. So that's one of my core papers this sem. So I've kind of taken it every year. So if you kind of have a knack for it, and if you like it in second year, you can kind of continue to take it in third year and fourth year, the kind of continuation of the same paper. Signal processing also, what signal processing is. So signal processing engineers kind of work on analyzing data, analyzing signals, and that's kind of applicable to radio engineers as well. So like network designs, and a little bit into the design, like engineering design as well. You kind of get to analyze signals, do a bit of calculation, how to improve it, how to get rid of noise, that kind of work. And a little insight into my background and my work experience that I've had so far. So I've been lucky enough to be a part of 2 internships so far. So my first year of my internships, which was in my second year, which is when most of us do our first internship, I worked at GEA Processing. They're a little firm in Mount Wellington. So we were working on a project for Fonterra. We were building them a milk powder plant out in, I think it was somewhere near Hamilton. Unfortunately, I didn't get to go on site because of lockdown restrictions, which is a bit of a bummer. It's always pretty great when you actually get to see the work you're doing. And it's definitely one of the perks of doing engineering, because everything that you're working on kind of behind the scenes, you also get to see how it turns out, like the final product. I'm currently working at Vinci Construction, and we're working on the City Rail link. Little insight into City Rail Link. It's a transport project that's coming up. It's a rail transport project that's due to finish hopefully in 2025. So I'm working at the Mount Eden station, which you can kind of see here. It's kind of a blurry photo, sorry. So I'm working at the Mount Eden station, so we're working on all the track equipment that goes on the track. So like the signals, like axle balizes, or the earthing that goes along the track, and also a little bit in the tunnels, or the cables that are going in the tunnels, and basically like kind of getting ready for that. I'll talk a little bit about like engineering and why I'm very happy I'm in this degree right now. I think the amount of, through university, you kind of get like your base knowledge, and you kind of get like all the tools that you need that kind of equip you for real life, like working on real life projects. But then when you actually get into industry and you get to see the kind of work that others out there are doing, you'll see how much your university background kind of helps you. You've got kind of the tools that equip you for to work in a team and to work on a project that's going to, impact society someday. The kind of work that I've got to be a part of, whether it's in the teams that I have at university or within the industry, it's been pretty amazing. And I think everyone around you impacts you in some way, and they always, motivate you, whether it's win. I think win is honestly one of the best parts of engineering that I've got to experience so far. The way they shape you and the way that they mentor you, it's pretty amazing. Whether it's so when I was in part 3, I had a part 4 mentor, and each year as you progress on, you have like a mentor who's like a year above you, kind of like a buddy who you can kind of go to with any problems you have. So it's been pretty amazing so far. I've got like a semester left, so almost there. Cool, thanks guys, enjoy your evening.
Awesome. And next we've got Shreya from Computer Systems.
Oh, hello everyone. So I'll start with a little bit about me. I'm Shreya and I'm in Part 4 Computer Systems. And I went to Linfield College. I don't know if anyone here is from there. So the reason I chose engineering is because at the end of high school I didn't really know what I wanted to do. I'm kind of someone that needs change a lot, and I really didn't want to do something that would put me in a niche sort of degree or area with my career. But I did know that I really love creativity and problem solving. And engineering is one of those degrees. It involves a lot of problem solving and a lot of creativity, because there's a lot of design in every spec. I also, as I said, didn't want to be stuck in one certain area, and engineering provides a range of career paths because they have 9 specializations, so it gave me at least 1 more year to pick what I wanted to do. And even beyond that, there's so much flexibility when you do pick your specialization in terms of what you want to do and where you want to go. But most of all, engineering creates meaningful solutions to real-life problems, which is and was a big part of my decision to pursue engineering. I wanted to do something that made a difference to people and solve real-life problems. And I thought, based on the people that I had heard from, this was a really good degree to do that. I think a big thing was in high school, I didn't really know what engineering was. I think everyone has a stereotype that it's just people fixing cars or sitting at a computer, and it's really so much more than that. As you'll see tonight, there's a lot of people who work on site and interact with real-life customers and solve real-life problems. I'll move on to the next slide. So basically, computer systems engineering, it's one of those degrees that no one really knows what it's about. I don't think a lot of people in our degree even know what it's about, and I'm in my 4th year. But the best way to describe it is that it's a mix of software and electrical. I would say that software sort of teaches you the algorithms and frameworks in designing software and coding, and electrical focuses on a lot of theory and design for the actual hardware side of things. But CompSys focuses on making hardware do stuff. So we program hardware to do what someone tells it to do. And that's a really cool space to be in because it's a really up-and-coming area. A lot of the stuff you'll see that uses CompSys would be smart monitors, like, things that turn the light on and off from your app, smart TVs, smart devices in your home, like Google Nest, all of those things. And so some of the things we learn about in our degree is microcontrollers and embedded systems design. And these include programming microcontrollers to make robots do things. We've also designed some smart energy monitors. So we weren't able to do this physically because of lockdown, but it's something that you can plug in and it can monitor the energy that a device is using. And so there's so many different things like that we do. A rough structure of our degree is in second year, where we first start the spec, is mostly theory. You'll learn a lot about electrical design and stuff. And then when you move into third year, you'll start doing a little bit more design components. And then finally in fourth year, most of it is complete design, and that includes hardware and software design. But from third year onwards, you can sort of pick the direction which you want to go, if you want to do more of a software-leaning degree or an electrical-leaning degree. And I think that's really cool because you get the opportunity to figure out what you like. Do you like electrical? Do you like software? Do you like being in the middle? And you can sort of frame your degree to match what you like and what you want to do. And that's really good for giving you opportunities once you graduate. Some of the social aspects of our degree are, we have barbecues through the department. We also get hoodies and teas. And there is an IEEE student branch that hosts a lot of events, mentoring, interview prep, networking, and all of that. So that's some fun stuff that is part of our degree, as well as other wider clubs like WIN, which is really, really amazing because CompSys does not have that many females, and I really want more females in our degree. But I've met so many other amazing females through groups like WIN, which has been really good for me. I'll go to the next slide. So now I'll tell you a little bit about my work experience and some places that this leads to. Currently, I work at a place called eRoad, and they make GPS monitoring devices for trucks and cars. And I worked as a firmware engineer with a little bit of software. And basically what I did was I got to try 3 different roles. I did some development. So they basically gave me a little hardware kit and a laptop. And it was all remote, so even if you're doing something hardware-based, you can work remotely. And I developed some things that they wanted me to develop and what they wanted the monitoring thing to do with the information. And it was really cool because you could kind of connect to it and see real-life drivers driving while I was doing stuff. And then I also did some testing and some quality assurance. So these are some of the roles you'll do if you do go into the industry. But there are more roles, such as consulting, working in startups, and a big thing that's coming up for CompSys is trading firms. They're using a lot of microcontrollers, and they're mostly in Australia, but they're big, big money. So if you're into that, you should do this degree. But some of the more household companies that have a lot of CompSys people are Fisher & Paykel, Apple, and Rocket Lab, and then some other places are Holter, Optiver, and IMC. So yeah, that's basically where CompSys leads to. I think a really cool part about CompSys is that because it's a mix of software and electrical, you have a lot of different things to work with. You can code something on a screen and see it right in front of you, and you're also using a lot of probing equipment to test out the different things and make different components. So if you're very into hands-on things, this is a really good degree. Yeah, I'll pass it on to the next person.
So next up we have Arsheen with ChemMat.
Kia ora koutou katoa. My name is Asheen. I hail to the beautiful region of Taranaki, and when New Zealand hasn't been in a COVID-19 lockdown, I have been based up here studying chemical and materials engineering. I have always had many interests such as food, photography, sciences, sustainability, travel, and cosmetics. And when I was younger, I knew that I wanted a career in which I could incorporate all of my interests and do something that adds value to people's lives. So what is chemical engineering? Chemical engineering is the scaling up of processes. And when I say scaling up, like process plants that are larger than the size of this lecture hall, and using high-level engineering to create a product that adds social, environmental, and economic value. I decided to study engineering because I'm a creative person with a problem-solving attitude. I like the idea that chemical engineers can collaborate with engineers from other specializations to innovate products that fill a gap in the market. I am also passionate about the environment and want to create ways in which society can thrive sustainably without compromising on modern-day luxuries and conveniences. This sounds really good, but let's be real. Engineering is one career that pays bloody well after just 4 years of study. And that was a big thing in making my decision making because I didn't want a lot of formal learning, but still be able to have a good head start in life financially. Chemical and materials engineering is not high school chemistry. But it will definitely help. You will use most chemistry principles such as oxidation and reduction, thermodynamics, stoichiometry, and apply them in the courses that are offered to you here. And learn to apply them in real-life engineering industries such as oil and gas refining, food processing, biochemical, energy, water treatment, and a whole lot more. And you can definitely see how diverse the specialization is. And so much more real than just chemistry. Chemical and materials engineering has two overarching fields of study, process engineering and materials engineering, and these are some companies that you could possibly work at. So process engineers use engineering design principles to optimize process operation plants and the production line. So what this means is we take a raw product, process it into something that's usable and could profit us in some way, because again, money. Materials engineers play a huge part in looking at a design and the specifications and deciding what is the best material to use for different scenarios so that the final product is efficient in terms of its functionality and lifespan. There is also the option of working in consultancies to have exposure to a diverse range of fields if you don't want to commit yourself to just one. Next slide. Thank you. So these are the subjects I did in high school, a good variety of sciences and arts, social sciences, and home economics. Being a passionate learner of both science and geography made me think engineering is the right career path for me, because I can take my science strengths and apply them to the concepts of sustainability and kaitiakitanga to make responsible use of our resources and to ensure they're available for future generations to use. In my first semester of university, I started a Bachelor of Science in Maths and Physics, crazy stuff, and changed to a Bachelor of Engineering in my second semester. This is the alternative pathway to engineering and shows how approachable this degree is from all different walks of life. Chemical engineering opens opportunities to work in traditional industries such as oil and gas, dairy, or something out of the box like cosmetics and pharmaceuticals. An industry that I've been involved in with is methanol production, so that's where I interned over the summer. It's just, yeah, good. No, it's all good. and I was their assistant process safety engineer, where my role involved supporting the senior process safety engineer to expose me to and be a part of the safety practices on their plant. I have learned that caring for the operators and contractors present on the plant is vital for a business to be successful and should be enforced as part of industry best practice. My dad is also an operator at that very plant, so that one really hits home for me. Studying engineering requires time management and some level of self-discipline, but sometimes you do need to cut yourself some slack and do things that make you happy. When I'm not studying, I am creating very fun content for the WIN socials. Cough, cough, make sure you follow us on the gram and the TikTok at win_UOA. You will probably see my face there to brighten up your day. And with WIN, I have had the opportunity to be involved with school visits, promoting women in engineering, both in my hometown of New Plymouth and travel to other parts of the country, like in Invercargill. We'll leave that there. I am also involved with the Institution of Chemical Engineers, also known as IChemE, as the student representative on their Auckland committee. So you can do a lot of things outside of your traditional studying. And I like to say engineering is my entire personality, so sometimes I have to put in the additional effort to get myself to do non-engineering things that I really enjoy, and that could be learning about politics and policy making, watching cricket, eating food, beauty, and exploring New Zealand. I enjoy my specialization as it ticks many of the boxes for me and gives me options for the future, and I'm sure it will be just as welcoming to you if you choose to pursue this. The ChemMat department at the university and the class size is small and a very tight-knit community. So it makes it easy to access support, but like anything else in life, you must be willing to take initiative. And it's the best way to get results. Thank you for coming out here and listening to me. And if you have any questions, put them on Slido, or come catch me after. Thank you, guys.
Okay, and next, my personal favourite faculty, the Civil and Environmental Engineering, Structural Engineering, it's a long name, and Zoe with structures.
Hello guys, I'll just grab my notes. Awesome, yep, so I'm Zoe. I'm in my 4th year of an engineering and commerce conjoint. So this is my last year of engineering and I have the commerce year next year. In commerce I major in finance and management, which is super fun, I love it-ish. So if you're wondering sort of what structural engineering is, it's really closely related to civil engineering. The way the degree is structured now is that it's 2 separate degrees, but it does have a common second year, so you do all the same papers in second year, and then from 3rd year you can sort of choose which way you want to go. So I chose the structures route. So what that kind of looks like is the design and construction of all sorts of infrastructure, so it could be buildings like this one, bridges, tunnels, but on a more detailed level, if you sort of look around the room now, they've got these nice exposed columns and beams. They're not just random sizes, you've got to make sure that it actually holds everything up and not just, the people sitting in here now. It's also thinking about what if an earthquake comes along and shakes the whole building, how's that going to impact the whole structure? And hopefully it doesn't fall down, that's always the goal. So in high school I took maths and physics. I kind of liked it, I didn't love it. So that's why I picked up the conjoint, because I wasn't too sure if I'd actually like engineering. But it ended up that engineering is way better than commerce, I have to say, just because it's more practical. So it's the same sort of concepts you learn in high school, except more real life. It's not just numbers, it's more actually impacting people's lives, which is super cool. And I also sort of like the idea with structural engineering that the projects are such a big scale, like this building, for example. You can sort of see everyone using it every day. and it's really impactful on people's lives, so which means you can get interested in or involved in really interesting projects. The one I put on the screen is from my internship. So I worked at a structural engineering consultancy. It's not been built yet, this is like the graphic drawings, but it's going to be the tallest residential tower in New Zealand. So it's 183 metres tall, and it's me standing in it, which is pretty cool. When I went, it was only up to the 15th story, but it was still really high, so I'm a little bit worried when it gets to like the 50th story. It's going to be pretty tall. And there's heaps and heaps of cool projects like that as well. So I put a couple other sort of bullet points of what else is involved in structural engineering. So there's a lot of the technical design, like I was explaining with the beams and columns, but there's also a lot of site work and analysis as well, which is super cool. Cool. Next slide. So in terms of the sort of work side of it, I kind of see that there's three main areas. So contracting is all to do with the actual building and construction of what you've designed, and it's a lot more outdoor site work, which is super good if you like that environment. There's also the consulting, which is more design and sort of drawings, calculations, and is more office-based work, which is where I did both of my internships, which I really enjoyed. It was nice to sort of get into the details and work with cool teams as well. But the third area I called it other fields, but it's really anything else. A lot of it is business applications as well. For my summer internship this year, I'm going to be at PwC in Sydney because they have an infrastructure advisory team. So there are a lot of more far out opportunities. You don't have to stay sort of in engineering, which is super exciting. And along with that, there are the overseas opportunities as well. Because New Zealand has such a seismic focus, like earthquakes and everything, that's quite useful to overseas where they might not learn that in different countries. So we have a lot of knowledge that maybe you don't learn in other degrees in different countries. And as part of that is why civil and structural engineering at Auckland is the 39th best university for that, which is like in the world, which is pretty cool. Yeah, super exciting stuff. But on the social side, we also have a student club. It's called Civil Engineering Students Association, but it's also includes structural as well. It's all kind of one big group. And we sort of host different events. We do social events and more networking industry events to help you with your career as well, which is super cool. Yeah, but yeah, put your questions in the Slido if you have anything else, and I'll pass on to Ray to talk about civil.
Cool. So hi everyone, I'm Ray. I'll start off with a little bit about me. So some of my interests include just trying new things, eating new food, and just like hanging with friends. And I found that it's really cool how engineering can let you do all these things, because this year for my internship I got to go away and do it in Wellington, and I got to see a bunch of cool new places, meet new people, and I thought that was really cool how engineering allowed me to do that. Yeah, actually, I'm a Part 4 student, and I also went to Mount Roskill Grammar, so yeah, thanks, thank you. Cool, so why I chose engineering. So I studied graphics in high school, and I thought that was really cool. I was actually really interested in architecture to begin with, but I ended up spending a lot of time just exploring what timber design was, and I thought that was really cool. I spent a lot of time on it. Basically, I was at home for 2 weeks, and that was kind of all I did. I explored it, I learned a lot about it, and I think that's where a lot of my interests come from. It's just from the time and effort I put into things, they just somehow become your passion because of all the care and effort you put into it, and I thought that was really cool. Yeah, and I think another reason why I chose engineering is that it has so many opportunities available to you, and I think if you want to take these challenges on and grab these opportunities, I think that you have real potential to be like a really good engineer, because engineering is all about like trying new things, like innovation and all of that stuff. And I think, yeah, engineering's cool like that. Cool, thank you. So a little bit about the things I did during my internship. So I worked for Holmes Consulting, and even though it is like very structural, I did a bit of civil stuff during my internship. So the photo on the left, it's actually like a debating chamber in one of the buildings we're working on. And I did a lot of beam checks. So if you guys do statics in physics now, it's a lot of like, checking the reactions at the end of the beams and like checking the loadings on the actual beams to make sure they work. And I thought that was really cool. And the photo in the middle, in my internship, I thought it was really cool because I got to go with a bunch of different engineers, just see what they were working on, see like the real big picture of what exactly I'm working towards. And I thought that just kind of like brought everything together to remind me of why I'm doing engineering in the first place. And the bottom photo, it's actually a bit of geotech. So geotech is a lot of like stuff to do with soils and foundations and piles. And basically, one of the geotech teams at work asked me to do a bit of soil profile of the place they were going to put some piles in. So basically, yeah, they wanted me to make it so that they could simulate some earthquakes to like shake up the soil and then see how the piles would react under that earthquake loading. And yeah. So what is civil and environmental engineering? So it's actually a bunch of things. Civil and environmental engineering includes transportation engineering. So transportation engineering kind of encompasses things to do with design, like say, how would you design a motorway so that it's safe at the speed you're going at? And if there's a really big curve, how big do you need to make that curve so that it's safe for everyone to drive on? And it also includes things like simulating traffic signals so that there's the least amount of delay at the given intersection, which I think is so cool because that's the kind of stuff you see every day, and then you actually know how it works. Environmental engineering, so in that photo, I think that's a wastewater treatment plant here in Auckland. So when we did environmental engineering in second year, we learned a bit about wastewater processes and basically how to clean and filter water so that it's drinkable when it reaches your house, and I thought that was cool. And coastal engineering, you learn a bit about, sorry, I don't actually know much about it, but I had to ask a friend, so she helped me out. So coastal engineering it's where you learn how coastal processes impact structures and people near coastlines. So basically you learn how to control hazards in the coastline, like in the photo shown, there's a little wall you can see just before you actually reach the road of that little town. So basically, it makes sure the waves crash early so that the waves don't actually impact like the pavement on the roads, and like the water doesn't actually splash people while they're walking or driving past it. And in civil engineering, as I mentioned, there was a little bit of geotechnical engineering. There's also hydraulic engineering and construction management. And yeah, basically within civil engineering, there's a lot of different ways you can go. And if you're someone who is really like stuck on making decisions, you're quite indecisive, I think it's a really good way to just see what your options are and see where you could go. But it can also be quite overwhelming just because there are a lot of options. And my best advice for you would just be to just try to pay attention to what kind of things you like to put a lot of time in, what you like to work hard for, because at the end of the day, that's the kind of stuff that you'll want to keep doing for the rest of your life, and I guess will make the bad days not so bad. Yeah, thank you. Thank you.
Sweet, and we've got Tessa from Mechanical.
Awesome. Hey everyone, can everyone hear me all good? Awesome. So nice to see so many faces coming out here today. I don't know about you guys, but I've spent a lot of the last few years sitting at home. So it's really nice to see some faces in person. Thank you for coming out in this bad weather. And to everyone online, thank you for tuning in. A little bit about me. I'm Tessa. I'm in my third year of study at the university, and I do a conjoint degree, which means I'm halfway through. For engineering, I do mechanical engineering. That's what I'm going to be talking to you guys about today. But I also do a conjoint with global studies, which I major in global environment and sustainable development. And I'm also learning French. I don't speak it yet, but I'm learning it. I went to Barradine College. Is anyone here from Barradine? Oh, disappointing. Yeah, and in high school, I really loved maths and physics, and I mostly just loved problem solving. And the key thing that I knew was that I wanted to do something where I could make a difference. I thought I wanted to do med, looked at it a little bit closer, I was like, maybe not. And then I discovered engineering. And what I love about it is the hands-on practical ways that you shape the lives of people around you. And that's ultimately why I chose mechanical engineering to specialize in. So what is mechanical engineering? When you think of it, you probably think of cars. You probably think of the mechanic that fixes your car. And that is a part of mechanical engineering, but what I think people don't realize is that it's so much more than that. And when I was trying to summarize what it is, I came across this definition that I thought was a really good explanation. So mechanical engineering is one of the broadest engineering disciplines. Mechanical engineers design, develop, build and test. They deal with anything that moves, from components to machines to the human body. And when looking at this definition, it really summarizes how I like to explain it. And when someone asks me, what do you do as a mechanical engineer? I say, I design and analyze things that move. It sounds silly, but it's true. If you look at the world around you, anything that moves, that is human-made, has in some way been designed or analysed by a mechanical engineer. And I guess that's what I really loved about mechanical engineering. I loved that the skills that you learn and the content that you study at university has a really practical application in allowing you to shape the world around you in whatever way you choose. And I love how broad mechanical engineering is because it can be applied in so many diverse ways. These are just some images that I've found of what mechanical engineering is. And as you can see from them, there's such a huge range, whether you really like the high-tech stuff like robotics, all the way down to something like these chairs. They were probably designed by a mechanical engineer. And for me, coming out of high school, as I said before, I chose to study engineering because I wanted to make a positive difference in the lives of people around me. And I loved that in engineering, I knew that whichever specialization I chose, I would have that ability to make a difference and to shape how people interact with the world around them. And ultimately I chose mechanical engineering because it gave me the most options with that. And it's currently my goal to work in humanitarian engineering. So I really want to work with lower tech solutions, not so much robotics, but things that are affordable and accessible for everyone. And so when I was looking at mechanical engineering, I loved that the skills that you learn can be applied in so many different ways, and that it can be all the way through to those high-tech robotics like drones and aeroplanes and high-speed cars, all the way down to those simple designs that people just interact with every single day. The other thing I really loved about mechanical engineering was the design aspect of it. It is so hands-on and practical, and you're really designing new things, and it lets you unleash a bit of your creativity. I didn't really consider myself to be a creative person because I cannot draw at all. And I was never very good at those kind of creative arts type things. But in engineering, I love the way that I can look at a problem and consider the whole range of possible solutions, and in my own way think creatively about how to develop a solution. So these are some of the projects that I've worked on so far. There's in a team of 4, I got to work on designing an urban transport vehicle, which is the image up in your top right, I think. On the left, we've got one of the designs that I just finished working on, where we actually got to go see it be cut and tested physically, which was really cool. With these, I just wanted to emphasize that mechanical engineering is so hands-on and practical. What kind of careers can you do with mechanical engineering? Well, these are just a couple of the kind of fields that you can go into once you graduate. A lot of people have mentioned these before, but
don't worry too much about these fields right now, because honestly, I don't know exactly what you do in half of them. But the main point that I'm trying to make here is that with a degree in mechanical engineering, there's so many different places you can go. You can do product design, consulting, construction, manufacturing, anything that you want. Because what you learn is how to problem solve, to think critically about a problem and develop a solution. And that's a really in-demand skill in industry. And what I've found with mechanical engineering is that your career options are really only limited by your creativity and your passions. And mechanical engineering gives you the tools to shape the world around you in the ways that you're passionate about and the ways that you're interested in. And so that's a little bit about mechanical engineering from me. But also I do want to say, don't worry too much now if you don't know which specialization you want to do, because I didn't know that when I was in high school. And I found mechanical engineering worked really well for me because it meant that broad, open option of being able to problem solve and make a difference in a really broad way. And if that's what you're interested in, if you're interested in problem solving and changing the world around you or changing the way people interact with it, then there is going to be a specialization in engineering for you. Sweet, I will pass it on to the next person. Thanks for listening, guys.
All right, thanks, Tessa. So next we have Michaela, and make sure, I saw there's a lot of questions on the Slido, so make sure you upvote the ones that you want to hear about, because we want to get through as many as possible.
Cool. Hello. My name is Michaela. I am a Part 4, so my last year doing Mechatronics engineering, and I went to good old Western Springs College. I guess next slide. Yeah, so how I got into engineering. So I think I never was really good at maths and science in kind of like primary school, and then I think one day I got dragged along to a robotics competition, and I found that like actually really interesting, and I saw like the application behind like the things I was doing, and I realized that I really liked problem solving. And from there I just started doing robotics, vets robotics in high school, and I think it's just kind of like always been what I kind of want to do ever since. So yeah, that's how I kind of did mechatronics engineering. Could you go back one slide actually? Ooh, yeah, that's the slide I want. All right. So yeah, mechatronics engineering is mostly known for robotics. So it's basically a combination of electrical, software, and mechanical engineering. It's a lot of people I know who take it are incredibly indecisive, like myself. So it's quite a good degree to take in the sense that you could either be a mechatronics engineer, or you could have a job as an electrical engineer, a mechanical engineer, or a software engineer. I personally, I just got given a grad role, and I'm now a software engineer apparently. Yeah, so I think it's quite a good degree for that reason. Yes. Okay, so in terms of like internships that I've done 3 in the past few years. My first one was with Women in Engineering, so I worked developing workshops for them, and I found that quite fun. My next one was at Crown, where I developed forklift software, and that was pretty cool. And then my last one was at an electrical consultancy called Flatsware, where I developed a smart stoke trap. So I basically designed circuit boards, ran around with antennas, looking like a crazy person, looking for aliens. And so I've done internships in a very broad range, and I found that really helped me a lot to kind of figure out my kind of niche, which is more in computer systems rather than mechatronics, but rather than mechanical, but it's fine because I have all these skills from my degree, so it's good to be indecisive in doing mechatronics. Yeah, so as I said, 3 main things. So electrical, very much like computer systems. So you do a lot of very hardware-based programming. Getting electrical components and timers to communicate with each other, and using very low-level code. The mechanical aspect can be design projects, and also fluid dynamics, which I later found out I did not like, but I know some people that do, and it is also very fun, in their opinion. Mechanical is great. And then you could also do the standard dynamics and kinematics, which is very similar to high school level 3 or level 2 physics. And you do a lot of things with that. And then software is a lot of like coding, but there's not a lot of it. So yeah, so I personally would have liked to do more coding, but it doesn't matter because now I can just, I'm pretty much a software engineer anyway, apparently, by some standards. Yeah. Next slide, please. Yes, so we have some cool groups. We have MECA, which is the Mechanical and Mechatronics Engineering Association. They put on some pretty fun events. What do? They have a pub quiz every year that me and my friends will go to and come last. They do just really fun, both social and professional events, which is pretty awesome. Yes, and I think I was going to say something about jobs you can get into. So so you basically, you can be software, electrical, or mechanical engineer. But also another fun fact is, as a lot of people have said, consultancies, a lot of what are the money people? The trading firms. Yes, a lot of trading firms will hire you. I think the main thing is doing an engineering degree. It doesn't matter too much about what you do. The main thing is that you come here to learn how to be a learner. And I think when you eventually go to industry, you learn a lot of things along the way. So, and I also actually had a job in science communication on a TV show. So that's another completely different area you could go into, I guess. So, yes.
Perfect, lovely, short and sweet. And next we've got, Sarah from InSci.
Kia ora everyone. As introduced, I'm Sarah and I'm a Part 3 Engineering Science student. I also take a conjoint with philosophy, which is a bit of a wacky one, but I'll explain that a little bit. So I went to St. Mary's College in Ponsonby. At high school, I took a really broad range of subjects because I was really passionate about a bunch of different things, and I didn't really know what I wanted to kind of specialize into. And kind of the thought of specializing scared me a little bit. So that's part of why the philosophy and Eng-Sci. So engineering is very much, is it right brain, left brain? I just wanted to engage as much of the brain for as long as possible. So philosophy's over here, engineering's over here. And as most people have said, I was really driven by a desire to help solve complex problems and that problem-solving brain. Next slide. So what is engineering science? It's a pretty big question, and it's one not many people know the answer to. So in its broadest sense, engineering science is using maths, physics, and coding to solve real-world complex problems. But that sounds just like engineering. So I'll give you a bit of an example of one of the projects I've done. Does anyone know where in the country this is? It's in New Zealand. No? So this is my hometown. This is Waihi Beach. It's just in the Bay of Plenty. And so that's some satellite data there. And so what this process was taking satellite imagery, splitting up the bands of the satellite data, and making an algorithm which decided what the land was being used for. So I identified a few points on here. This was water, this is highly vegetated, this is sort of urban or farmland, and then created an algorithm which could sort of predict what the land was being used for. So you've got the highly vegetated in the yellow, and the green is lower vegetation, blue's water. There's an example. Sorry, next slide. Cool, so engineering science is really about developing a toolbox. In there, that's my toolbox. So it's a lot of data analytics, lots of design thinking, mathematical modeling, machine learning. And it's not so much about what you're applying those tools to, like what context. It's not specifically electrical or mechanical or civil context, but it's about giving you the tools so that then when you're thrown into a new context, you can find a way of finding solutions in that context. So one really cool thing about Eng-Sci is it's a super customizable degree. So in my degree, I have 7 electives. Electives are courses that you can choose from anything. So my toolbox looks very different to a lot of other people's toolboxes within engineering science. So a little bit about engineering science jobs. You've got this toolbox, you've come out of uni with a bunch of tools, and what's really cool about Eng Sci, and it's come through in a lot of the other specializations as well, but you can go into a lot of different areas because those tools are not area specific. So yeah, there's a few of them up there. I won't talk through them all, but I'll talk a little bit about my experience in my most recent internship. So I was at this company called Transpower, it's an organisation called Transpower. They own and operate the New Zealand electricity grid. So most of the people there were electrical engineers, as you'd imagine. But I found that coming in with my Eng Sci toolbox, I was able to apply these tools to the electrical engineering context. Once you're in industry, they teach you a lot about what the company does, their systems, their processes. And I was actually able to report on a bunch of different, their different assets and help explain why certain power outages were higher in certain areas than others. Yeah. So overall, why engineering science? I would consider engineering science if you're really excited by problem solving. You love learning and a bit of a challenge, because it is a little bit of a challenging specialization. If you really like asking questions and you want to work in a range of jobs, or at least aren't ready to choose what you want to do yet. Most of all, and I think this applies to all of the engineering specializations, you're a creative and big picture thinker. Cool, if you've got any questions, feel free to talk to me afterwards.
Awesome. And last but certainly not least, we have Brittany.
Yay. Hello, everyone. My name is Brittany. I'm in my 4th year of biomedical engineering, but I'm not an Aucklander. I'm originally from Nelson, so I went to Waimea College. I see Paige hyping that up at the back. So basically, I was very indecisive with what I wanted to do. I had no clue. I applied to 4 different unis, 2 different courses at each. I genuinely had no clue. For me, why I chose Auckland was at Auckland Uni, they basically have most of the degrees that I was applying for, so I could do law, I could do arts, I could do engineering. Basically from that, I decided to go with engineering because it delayed my decision even further. So with the first year engineering, it's general, so it was one less decision I had to make. If I had gone to Canterbury, which was where most people from my high school went, I would have had to choose more specialised, what my specialisation would be. Another reason I also chose Auckland was because biomedical engineering isn't anywhere else in the country. So I wanted to leave my options open and have that as an option at the end of first year. I'm grateful I did because I really love it. So for me in high school, there may have been a hint that I was into engineering, given I really loved electronics and I did the international physics tournaments, which was lots of fun. But I have to say I wasn't hugely into maths and physics as NCEA subjects themselves. So if that's not a big thing for you, that's also not that important. There are important skills to get and to tick off the box, but you don't have to be in love with them because there's so many other aspects to engineering. Also, for any of the people online, I moved from Nelson and it's definitely a big move. I knew no one moving to this city, but I've made a great support network. WEN's definitely helped with that, so don't be scared of doing that. Okay, so you might be wondering, what is biomedical engineering? Most people assume it's just designing prosthetic limbs for people. That's the very common one. I can tell you that's barely in there. That's more of a mechanical engineer's role. So basically, you are the jack of all trades. These people have told you about how diverse the engineering degrees are. I can tell you, we can one-up them. We pretty much learn a different paper from most different specializations. For example, this semester I'm doing one from engineering science, I'm doing one from chemical materials, and I'm doing one biomedical engineering specific one. So just to give you an idea. It's such a diverse range of skills which can still be applied to different fields, not just healthcare, although most of the papers are centred around healthcare problems, but those skills are still manageable for different contexts. For me, When I was choosing my specialisation at the end of first year, I was torn between mechanical and biomedical engineering. For me, I ended up going with biomedical engineering because you learn these mechanical skills, but I thought it was in a more interesting context. So instead of designing a little car or something like that, I could design a medical device that could help someone. And we actually worked with clients. I just had a design project with a doctor advising us on problems he'd like fixed. So that's really cool. So the culture in biomedical engineering is probably quite a bit different to most other specializations because there's only about 30 or 35 of us in the class. So it's far more like high school. You get to know your lecturers, you can easily ask questions in class, and it's really a relaxed environment. We also, us in engineering science, are the only department to get a field trip. So we go stay at Rotorua and Taupo for the weekend, which is super cool. You get to meet your cohort, and that's at the start of second year, so it's designed to make friends, that sort of thing. You also visit energy plants in Taupo, so I went to go see Contact Energy. You got to see the geothermal plants in that, so that was really interesting. There's also the classic Engineering Society Club, and barbecues, those sorts of things. So to give you guys an idea of how diverse biomedical engineering can be, these are my two internships, completely different things, right? So my first one at the end of second year was working for a startup called Engender Technologies, and what we were trying to develop was a sex semen product. Basically, in the dairy industry, you need only female cows, right, to produce your milk. Currently, they inseminate cows, the bulls, with semen, and it's all artificially done. And the majority of that, obviously 50% of those cows will be male, and then they'll be killed 2 weeks after birth. This was trying to develop a technology which would avoid that, and so you could use female-only semen to decrease the amount of deaths. So yeah, I just worked in a small R&D company, and yeah, working with that. It was super cool, but very academic and very small scale. Then I went to the opposite end of the spectrum, the largest New Zealand healthcare company, at Fisher & Paykel Healthcare. I was in the laparoscopy surgery team, which is keyhole surgery, and I was helping design a product for that laparoscopy surgery which would help surgeons and help the treatment for the patient. Basically, I was designing a device and it was used in the preclinical trials, so on pigs, and that's really cool to see something that you've done actually used in practice, especially as an intern. My role at that company involved all those different skills alone. I basically developed an entire product that was used in the practice. So the mechanical design, electrical design, and software design. I also learned lots of skills in machining, which is something that mechanical engineers might do too. Yeah, it's really cool. Something I should point out is for a lot of people who might be considering medicine, we do medical science papers, so it's very similar to medicine. They're taught by mostly the same lecturers, but yeah, we do a small selection of them. I find it really interesting to just have that small bit of physiology learning, that sort of thing, but I wouldn't want to study a whole degree in it. But I think a lot of people, when they're considering medicine, are thinking about the roles that a biomedical engineer might do. They might think about trying to help people, but if you're thinking about helping people on a wider context instead of, I suppose, like a general practitioner context, biomedical engineers can definitely help with that. Yeah, you still can help people, I suppose, and it's still very applied within the healthcare industry. You're trying to make the lives of surgeons and physicians and that sort of thing easier. So these are a couple of my projects that I've worked on recently. So you can see I did a model of a plane wing. So we were designing the spar that goes through that. You might think very mechanical project, but we still definitely learn those skills. This is my Part 4 project. So I'm These are all the muscle fibers from a typically developed child in his lower leg. And basically, I'm creating a model to compare the muscles between a child with cerebral palsy and a typically developed child. So it has a practical context, and it should be really interesting to see the results. And this semester, we also designed a medical device. So we had a client who's an oncologist at Auckland City Hospital, and basically the majority of cancer patients with head and neck cancer experience xerostomia. So that's where they have no saliva in their mouth or very little. And this product was trying to treat that. So yeah, you can see there's like a huge range of problems that you're solving, and yeah, I find it really interesting. So thank you.
Alrighty, we're just going to try and zoom through a quick Q&A. Q&A now. Yeah, so if maybe we can get a couple of the speakers to come up the front and then just sit along here, and then, yeah, just a couple. And then we'll go through some of the most upvoted questions. So I might just pass it to one speaker and then they can explain, just so that then we can knock through some more. So one of the questions was, how competitive is engineering? Is it hard to get in? So would anyone like to start off with that, or we can pass it along? Anyone wants to start? So how competitive is engineering, and is it hard to get in?
I think no. Because we have, 1,000 first years come in every year. And majority of the time, every one of them ends up with a specialization, compared to like your typical health sci biomed degrees, where if you want to do medicine, the cut is quite harsh. So yeah, I think it's quite chill.
Okay, so our next question is, what degrees are best for conjoints with engineering in terms of balance and also being relevant to engineering?
Which degrees are best to conjoint with engineering? I can definitely talk about this one a little bit, because I do a conjoint with global studies, and I think it really depends on what you're wanting to get out of the conjoint. A really, really common conjoint to do is commerce. You will have seen that with some of the people here, and that often lines up quite nicely, and Jenna can correct me if I'm wrong here, but a lot of the consulting finance companies, you're learning the business side of it, but engineering in itself is a skill set. And something that I was thinking about when I was in high school is that even if I don't become an engineer, an engineering degree is still going to be super, super valuable in whatever career field you end up in, because you're learning problem solving, you're learning critical thinking, you're even learning things like leadership. So with something like business, the two degrees line up really nicely and can kind of streamline you into the same career. So that is a very practical example of a conjoint option. I do global studies, which is maybe less obvious how it makes sense, but for me, it's a passion thing. And as Sarah was saying before, for me, global studies is arts. It's very creative and essay writing, and there's no right or wrong answer. And engineering's kind of on the other side of the spectrum. And I really love that, because I think it gives me a lot of balance in that if I'm really not feeling the math today, I can take a break and I can start writing my essay and start thinking with that side of my brain, and then swap back and forth. And conjoint degrees like that are more, they're passion driven, and they might be a little bit more niche as to where you want to go. So I want to work in development and humanitarian development, and so I effectively do development studies, and I look at the social impact of engineering projects while learning the technical skill set of how to implement those. So those are kind of two different examples of conjoints that you might decide to do, and it really depends on what you're interested in. If you are interested in doing a conjoint, I personally would say go for it. When it comes to actually doing the degree, it does take longer and it can be a little bit more difficult, but if you're passionate about the conjoint, it is 100% worth it. Yeah, and I would just like to add that you can pick up a conjoint later on. Like I did pick mine up in second year, and it just meant that I had to do a few more 5-paper SEM courses. So 5-paper SEM, 5-paper semesters is what I meant, sorry. So don't think it's like the end all if you don't start off doing a conjoint and you want to do one later, and vice versa. There's been so many people that have dropped their conjoint as well. So if you're interested in it, I would recommend starting it and see if you still want to pursue it later on.
Awesome. And our next question, to be an engineer, do I have to love maths or physics, or can I just like them to be successful? How much is theory, maths and physics part of engineering?
I'd say you definitely don't have to love maths and physics, but you will have to appreciate it as a skill that can help you get where you want to go. So for me, right, in high school, I did not love maths and physics in the classroom. I struggled to see the relevance of it, whereas in engineering, you can see the relevance of it so much clearer. And I find that very useful. And even though you're using the same skills, because it's in an applied context, it's so much more manageable and so much more interesting. Also, so in high school, I did the physics projects. I, for once, designed a pendulum on a cart, which was a device moving under chaotic influence. That's a form of physics, and I was modelling it, and I found that really interesting, and that's far more relevant to engineering than NCEA standard would be, for example. So if you like the application and wanting to know how things work, maybe you watch how things work YouTube videos or something, you probably would enjoy engineering a lot more than whether you like writing out your quadratic equations or something like that. Yeah, it's an important skill, but yeah, you don't have to love your high school work.
And I would just also add it depends a lot on what specialisation you choose. For example, I did math, but calculus is not my cup of tea. I do mechanical engineering. There's a lot of physics. If you pick a different specialisation, you will be focusing more on certain parts of the maths or physics. So if you don't absolutely despise every minute you spend doing them, then engineering is a good option, and there's probably a specialisation that has the parts of it that you like and maybe not so much the parts you don't.
Awesome. So our next question is a spec-specific one. So what do you do mostly in civil engineering, and how is it different to architecture?
Personally, I don't know much about architecture, but I can say that with civil engineering, well, structural engineering in particular, you do a lot of design work. There's a lot of standards that you have to use to make sure that beams are okay. So for architecture, you're focused more on the creative side of things, like how the building looks, how people will feel in it, like how the flow is. But for things like structural engineering, you're kind of just making sure you're working with the architecture so that you can make their designs work and make it look good, but also be structurally sound and that it's safe for people to use. Yeah, that's my difference. Do you want to add anything to it?
Yeah, I guess there's also a creative aspect in the engineering side of buildings. So if you did want to sort of still be working with architecture, there's a lot of Ray could probably speak on it a bit more as well, but with timber design in particular, there's quite an emphasis on how it looks. And I think it's more interesting on the engineering side because you get to put together how it looks and how it's actually going to work, which is pretty cool. Yeah.
Awesome. And we have another spec-related question, which is, what is the difference between computer system and software engineering?
So basically, in my eyes, Jenna can correct me, but software kind of focuses on the high-level code, and computer systems focuses on low-level code. And for a really long time, I didn't know what the heck that meant. But as I've gotten through my degree, now I realize that software is sort of how it interacts with the user or the person using the software. So they develop code that a real life person can, interact with. They have a front end and back end. So the front end is sort of you interact with it, enter the details that it's asking for, and then the back end processes it. CompSys, on the other hand, is low level code, which means it's focusing on programming hardware. And so we don't really interact much with people as much, but we interact with requests or requests from things. And that could be from a person, but we don't really focus with the people side. We just care about the request. And then we make the hardware do stuff. And we focus on very different languages in terms of that. So we focus a lot on C and C++ and Python. And I guess for us, the main difference is we're programming, like, for example, we have a board with pins on them, and then we program what each pin does. So if you want to turn an LED on because somebody pressed a button, that's what we do. And software.
Yeah, so I think what Shreya mentioned was like mostly true. So with software, we don't really interact with hardware. We think more like about more higher level. So for example, in one of our courses, it was about, it was called software architecture, and we learned how something like Facebook works, like how it's split up to so many different components, and how you would have, you know, a database, and how it would flow towards like your middle layer, and then how it would come to your front layer, which is what you see on the screen. So it's a lot more like, it's less hardware focused is what I say software is for. And if you want to become a developer that works on web applications, you want to work in those big tech companies like Google or Microsoft, then you'd probably want to study software engineering, yeah.
I will just add to that. We're kind of similar in the sense that with low-level code, we also focus on how much memory something needs to work and stuff. And so if you want to work with, like, I guess Apple uses this a lot, like firmware engineering, because they design like processors for their Macs or new devices and phones. And so they use a lot of this to sort of figure out how much memory they need to make a certain feature work or a certain aspect of their design work. So you can totally work in any of those companies with ComSys as well. It's just focusing on a completely different side of it.
Cool. So our next question is, how does NCEA subject scholarships in Year 13 impact engineering in UOA? And also, if any of you could speak towards university scholarships?
I need two of those.
Oh,
yeah. So how does NCEA scholarship specifically? Yeah. Oh, wait. So I did take a NCEA scholarship for like one course, but I don't think that's really what the question is asking. Yeah.
Oh, I can do it. I can.
But sorry, I'll just say one thing. I did also get a separate scholarship, and there's plenty of scholarships for women in engineering. So I got one that covered all 4 years of my degree, which is pretty cool. So definitely, I would recommend, if there are scholarships, apply for them. It is definitely worth it. I almost didn't apply for the scholarship, and then I got it, and it was like such a nice surprise. So.
Yeah, I guess I would definitely second Michaela's message about applying for scholarships. There's lots out there, especially for women in engineering, because we are sort of underrepresented currently. So definitely apply. I think if the question's asking about NCEA...
Like scholarship subjects.
Scholarship subjects, yeah, I did a couple of them in high school. I mean, if you're asking whether it's an indication of what you will learn in that first year, definitely there is some overlap, and I found it helpful to sort of stretch myself to those scholarship levels. It gave me a little bit of a boost straight up in first year. I don't think the University of Auckland lets you skip any of your first year engineering courses, if that's what you're asking. But yeah, definitely worthwhile doing, and there's a money reward to those scholarships as well. So if you can get those, it's definitely worth going for, in my mind.
Another thing, so at UOA, your scholarships from NCEA do not have any impact on your engineering degree at all, other than you may learn some extra stuff for it, maybe with the calculus and physics ones more important. But for me, I only did scholarship chemistry because my school put no emphasis on scholarships and there was no additional support for it. So if you're worried about doing it or not doing it, don't stress about that decision. It's not going to be probably a significant one in your life. Don't put too much pressure on that decision. Just do your best and do what you want to do, I suppose.
I would definitely agree with that message 100%. However, I would say if you are wanting to do scholarships, I would say that scholarship calculus in particular the skills you will learn in it will be helpful in your first year, particularly calculus and physics being the main subjects that you need in NCA to then come into engineering. The physics is helpful, but in scholarship calculus you may, if some of you are doing it, you do start to learn new skills in high school that they will teach you again in first year. So if you are going to do it, you will appreciate it in first year. However, I did not do it, and that's okay too. But calc in particular, you will learn some stuff that will be helpful.
I was one of the people who took the Maths Accelerated course while I was still in Year 13, so that's when you take this paper specifically designed for people who took calculus a year early, and so I did that when I was in Year 13, and that means that you can skip the first year of your first year math paper, although it is quite hard. But if you do that, it is a very interesting learning experience, and I think a lot of schools do that, so would recommend.
The people online, sadly, that is only available for Auckland students because you have to come in person to do it. There is a Canterbury Maths one that you can do away from home, you could do it from Nelson, which is cool. But yeah, it doesn't apply quite as well as the Auckland one because the Auckland one's designed as a kind of precursor to engineering, I suppose.
Awesome. And the last question, why should I study engineering at Auckland University compared to Canterbury or AUT?
I mean, I can go for this given I've applied to 4 different universities, so I've done my research in this. Okay, for specifically engineering, there's 10 different specializations, whereas none of the other unis have that many. So it means if you are unsure, you have all of the options there pretty much. Secondly, there is biomedical engineering and engineering science at Auckland. These specializations are not anywhere else in the country. Canterbury will try and tell you they have biomedical engineering alongside their mechatronics degree, but they don't have any medical papers, so it's more like mechanical or mechatronics applied in a bioengineering context, rather than learning about physiology and how that relates to engineering, I suppose. So there is a bit of a distinction there. Additionally, Auckland is fairly nice for scholarships. So I got the Top Achievers Scholarship to come here, so that's $20,000, whereas Canterbury doesn't have the same, I suppose they have a large scholarship, but it's for far fewer people. So in my year, they only gave out 30 scholarships across all of Canterbury Uni, whereas the Top Achievers one alone gave out like 230, I suppose, so your odds are a bit better. Saying that though, Waikato University is pretty good with scholarships also, and they do have engineering there, so yeah. And then Victoria is one to go to if you're into more game development or security engineering, because they're the niche that Vic offers, which Auckland doesn't, and that's kind of where they differ. But that is quite a niche, so I'm not sure if anyone's into that sort of thing. But yeah, they're kind of the differences between the engineerings. Yeah.
Awesome. Thank you guys so much. Can we get a now, there were a lot of questions that didn't go answered, so please come up to any of us and ask them if you still want them answered. We're all very friendly, I promise. We won't bite you, so just come up to us while we're eating pizza. Okay, so really quickly, we have a lot of things left going on for this year for high school students. So one of the things we have is the buddy program. I know we just had an event right before this, and we were playing with lasers, which was super awesome. So make sure you sign up. We have, I think, 3 or 4 events left for the year. So yeah, get involved with that.
And as we mentioned a couple times previously, we've got the Ingenuity Day, which is on July 14th, and you guys, your career advisors at school should be giving you guys some more information about that. Otherwise, if you look at the WIN website, there's loads of information, or come up and ask us about that. But it's a really cool day where you get a bunch of free food, and you get to design and get your hands dirty with some engineering related challenges and projects, which is super fun.
Okay, we also have a CAD competition coming up, and you don't need any pre-existing knowledge of CAD. Everything is taught to you through tutorials, and it's really cool. You get to design a keychain that you feel represents you. So go onto our website if you want to learn more about that. Really cool opportunity to get involved. Yeah. So as you can see, we have a lot of things going on. If you scan this QR code, or if you just go onto our website, you'll be able to see everything that's going on, because we have a lot of things offered to high school students, so make sure you make use of that before you come into university.
And lastly, the most important thing for all of the content that these ladies work so hard to produce, we've got the WIN Instagram and the TikTok. So take a photo, chuck that all a follow, and you'll be updated on everything that's happening.
Okay, one last thing. We do have, did I do that too quickly? Yeah, we have a mentee to get some of your feedback so we can keep doing this event and make it better and better for the future years. So if you could please fill it out and let us know how this went. Much appreciated.
And then we will promise to give you food afterwards. I know you're starving. We are too. We're almost there, almost at the end.
So we'll give you guys 5 minutes to fill this out.
Awesome. Oh, yeah. It's only 10 minutes late. Not bad. Yeah, not bad.
I should have saved my book too.
Mm-hmm. 2 minutes. Did you think that's enough time? Pardon? 2 minutes is enough time?
I think they're all pretty much